Dear students, in the last class we have discussed surface areas and volumes, their formulas, and we have discussed three problems of first exercise. Now, the fourth problem of the first exercise. Everyone, take your textbook in front of you and read the question. First exercise of surface areas and volume, question number 4. The question is a cubical block of side 7 centimeter. What we have? A cubical block. Cubical in the sense all the sides edges are equal. Cubical block of side 7 centimeter. 7 centimeter. Height, breadth, length, everything is 7 centimeter. Okay. Is surmounted by hemisphere. Is surmounted by hemisphere. So what is hemisphere? Half of a sphere is hemisphere. So surmounted by hemisphere in the sense this hemisphere is placed on our cubical block. Example, see the diagram. This is our cubical block. On this cubical block, an hemisphere is placed over it. Hemisphere is placed over it. The first question he is asking is what is the greatest diameter the hemisphere can have? What is the greatest diameter? See here, when the edge or the side of a cube is 7 centimeter, then the hemisphere can, when it is surmounting the whole cubical surface, the highest diameter can also be 7 centimeter. Second question is find the surface area of the solid. After placing hemisphere on a cubical block, what is the surface area we have to find? Okay, dear students, see here. First question, what is given to us? Given side of cube, cubical block, nothing but cube is equals to 7 centimeter. Hemisphere is hemisphere. What is hemisphere is surmounted, surmounted, surmounted on cube. Therefore, the highest diameter, the highest, the highest diameter, diameter of hemisphere is equals to how much? When the hemisphere surmounted on a cubical block, when hemisphere is surmounted on a cubical block, then its diameter must be equals to length of the edge of a cube, that is 7 centimeter, is equals to edge or edge of cube. Okay, therefore diameter of hemisphere is equals to 7 centimeter. Similarly, radius is also 7 divided by 2 centimeter. Right? Understanding? Look at here. When the hemisphere has diameter of 7 centimeter, its radius must be half of that. So d is equals, diameter is 7 centimeter, r is equals to d by 2, that is 7 by 2 centimeter. Right here, what you have to write? Given side of a cube is equals to 7 centimeter, hemispheres are mounted on a cube, therefore height of the diameter of a hemisphere is the highest, not height, highest diameter of hemisphere is equals to edge of the cube. So diameter of the hemisphere is 7 centimeter, its radius is 7 by 2 centimeter. Now total surface area of the solid. Total surface area of the solid. So dear students, what we have here, the solid is what? Cube. So the total surface area of a cube is 6a square. 6a square. So now what is placed on it? Hemisphere is placed on it. So we have to write CSA of hemisphere here. CSA of hemisphere. Because on cube, what we are placing? We are placing hemisphere. So here we need to mention CSA of hemisphere. The CSA of hemisphere is 2 pi r square. Right? Cubical block is over, total surface area, and CSA of hemisphere is over. But one thing, if you observe this diagram from the top, you can see that on the above edge, on this above edge, what is placed? Hemisphere is placed. So one edge of it is covered by a circle, which is base of our hemisphere. So this circle has to be subtracted. Circle has to be subtracted, that is minus pi r square. This is total surface area of a cube, hemisphere. Okay, next, on this one edge a circle is hidden below, so we have to subtract a circle from it. 6 of 7 square plus 2 into 22 by 7. So what is the radius? We got it as 7 by 2. We have r square, therefore 7 by 2. Before that, dear students, we can even simplify this. 6a square plus what we have here, 2 pi r square minus 1 pi r square. So just we can write this as pi r square. So now simplification will become very easy. Plus 22 by 7, then what is the radius? 7 by 2 into 7 by 2, which is equals to 6 of 7 square is 49 plus 7, 7 ones are 7 ones are cancel, 2 ones are 2, 11s are, right? Then we have 11 into 7, 77 divided by 2. So which is equals to 49 6 are how much? 290. How much? Tell me. How much? 294. Very good. Plus 77 by 2 is how much? 38. Yes, calculate 38.5. So adding these two, 294 plus 38, adding these two to 294 plus 38.5 is equals to 332.5 centimeter square is the total surface area of the solid. Understood? I will give you brief explanation. We have a cuboid. On one edge of the cuboid, what we are placing? We are placing a hemisphere. We are placing a hemisphere. So total surface area we have to calculate: 1 2 below 3 4 backside 5 above 6, right? So that is 6a square plus what is surmounted here? Hemisphere, that is 2 pi r square. But here, if you have both are the solids, right? When you surmount an hemisphere over it, this surface is hidden below, but the little portion is outside. So what portion is outside? A square minus a circle portion is outside. So we are subtracting one circle here. Understanding? So which is equals to 6a square plus pi r square. Okay, write in your notes. Now I will go to the next question. Question number 5. Read out the question. A hemispherical depression is cut out from one face of cubical wooden block. See here what he has. He has a cubical block. Okay, from this what he is doing? He is one face is being removed, a hemisphere. Listen here. A hemispherical depression is cut out of one face of a cubical wooden block. Means when we have a cuboid, a solid cuboid, what he is doing? He is digging out. He is from one side. He is removing out a hemisphere, hollowing out your solid hemisphere. Understanding? slowly he is making a depression, means removing the portion. In what shape he is removing? He is removing in the shape of hemisphere. ಅಂದರೆ ಕ್ಯೂಬಲ್ಲಿ ಏನು ಮಾಡ್ತಿದ್ದಾರೆ ಅವರು ಸ್ಲೋಲಿ ತೆಗ್ ಮಾಡ್ಕೊತ ಹೋಗ್ತಿದ್ದಾರೆ, ಅದಕ್ಕೆ ಹೋಲ್ ಮಾಡ್ತಿದ್ದಾರೆ. ಯಾವ ಶೇಪಲ್ಲಿ? ಹೆಮಿಸ್ಫಿರಿಕಲ್ ಶೇಪಲ್ಲಿ ತೆಗ್ ಮಾಡ್ತಿದ್ದಾರೆ. ಓಕೆ, see the question once again. The hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of hemisphere is equals to the edge of the cube. So how much wide they are cutting this? How much wide they are making the depression? The depression of hemisphere and the width of hemisphere is equals to the width of your cuboid, means edge of cube is equals to diameter of hemisphere. Diameter of hemisphere. Okay, so that is given as L. So therefore what is the radius? Radius is equals to L divided by 2. Determine the surface area of the remaining solid. So after digging out the hemisphere, from this solid, what they are asking, find the total surface, determine the surface area of the remaining solid. So first, from one side we are digging, but all the 5 sides are no changes. So total surface area of solid is equals to, first thing is 5 sides are safe, or you can take all these 6 together, 6a square, but one of the sixth is removed in the shape of a circle, right? So minus pi r square, it has been digged in the shape, means scoop ಮಾಡ್ತೀವಲ್ಲ ಐಸ್ ಕ್ರೀಮಲ್ಲಿ, ಸ್ಕೂಪ್ ತೆಗೆದ್ರೆ ಹೆಂಗೆ ಒಂದು ಕಪ್ ಹೊರಗಡೆ ಬರುತ್ತಲ್ಲ ಅದೇ ರೀತಿ ಸ್ಕೂಪ್ ಔಟ್. ಸೊ digged in the shape of a hemisphere. ಆ ಶೇಪಲ್ಲಿ ತೆಗೆದಿದಾಗ what happens? Will be having a scooped shape, that is nothing but hemisphere shape, plus pi r square. So which is equals to 6a square minus pi r square plus 2 pi r square is plus pi r square, which is equals to 6. What is the side? L. It is given as L. Pi is 22 divided by 7. Radius is L by 2 into L by 2. So 2 ones are 2 11s are, which is equals to 6 L square plus L into L square. We have 11 here, so 11 L square, 7 2s are 14. So now take down the LCM. Here we have 1. Take down the LCM. LCM is 14. Multiply this with 14. 14 6 are 84. So we have 84 L square plus 11 L square, which is equals to 95 L square divided by 14. Okay, dear students, practice these two and try the sixth one. Try the sixth one. I will explain what is the concept behind it. You try on your own and send me those answers by tomorrow, what you have solved. If there is a mistake, I will correct you. And few people didn't understood how to do that. I will make a video of that again, or I will explain that in a live class. See, the next question is, medical capsule is in the shape of a cylinder with two hemispherical stuck to each. So diagram is given to us. Leave it. So this is a medicine capsule is in the shape of a cylinder with two hemispherical structs. How the diagram is given in textbook is, stuck to each other of its ends, the length of the entire capsule is 14 millimeter, and the diameter of the capsule is 5 millimeter. Find the find its surface area. You have to find the whole surface area of the capsule. Dear students, the above diagram, we can rewrite this as, this is the capsule, right? What he is saying, the two ends are hemispherical in shape. Hemispherical in shape. Instead of cutting, let us cut these hemispherical shapes. Here the entire length is how much? 14 millimeter. But the height of this capsule is 5 millimeter. This 5 millimeter is nothing but height of your hemisphere, or diameter of hemisphere is also 5 millimeter. Then what is the radius of this? Half of it. That is, radius is equals to 5 by 2 millimeter. Millimeter. Right? Therefore, this height is also 5 by 2 millimeter. Similarly, how to calculate the total surface area? Here we have one hemisphere plus two hemisphere plus cylinder. Look at here. The above diagram is in the shape of cylinder plus hemispherical ends. So the total surface area, how to calculate? These two are attached to each other. These two are merged inside. So we can't see this. How to calculate total surface area is CSA of this hemisphere plus CSA of your cylinder plus CSA of this hemisphere. Nothing but 2 CSA of hemisphere plus CSA of cylinder. Okay. Do in this way, you will understand. Okay, students. Thank you.